Hi class, I wanted to just do a little quick video on using MATLAB and turning in your MATLAB assignment. And this is actually the second time I've recorded this because you can see here I've done it before, but I forgot to turn on the volume the first time. Or actually I forgot to pull down the little thing I speak through to being in front of my mouth so you can't hear anything I'm saying. So since I've already done this once, I may refer to it. But I'm going to start a fresh uh, session here. And so starting from a fresh pane, this is the desktop version of MATLAB. You could use the online version of MATLAB too. That would work just as well for what we're doing here. But you can I would click this new live script. I like this live script better than the standard script. And because we can make these little boxes and run little cells, it makes things a little bit easier to debug and play with. Okay, so here's a new live script. Okay, let's see. I've already got this one titled Chapter 2, Exercise 4. So let me title this one something really great. Let's see. Change the title. Okay, how do I retitle it? That's interesting. Oh, I know. I remember. Okay, sorry. Silly stuff here. I guess it's save as, where's save? Yeah, okay, so save, right? If we save, okay, it's going to ask us for a name, okay, and so I'm going to say Chapter 2, Exercise 4, Take 2, okay. So let's see, there's some naming rules here. You can't have spaces, and I think your name of a file can't start with a number, so MATLAB will warn you if you try to do something wrong there. Okay, so there we go. So it changed its name, and now we're just going to follow what the book has for us. So this cell is a thing that opens up, and we can run stuff in it, and I'll show you that here in just a second. In fact, let me get rid of some of these variables and stuff. So clear is a nice thing to know. It just gets rid of all the variables that have been defined. Let's see, I think CLC will get rid of all this output there. Okay, so there we go. So it looks kind of clean now. Okay, so let's see. So here's our problem number 4. By the way, these MATLAB assignments are in your text. And you see here's chapter 2, and here's the MATLAB exercises, right? So if we can click on there, you see MATLAB exercises, and we're doing number 4 here. Okay. Okay, and it says, to start off with, we're going to generate a 6x6 random matrix of zeros and ones. Okay. So this part of the command here, rand6, will generate a 6x6 matrix of random numbers between 0 and 1. So let's just try it out. Rand6. All right, it'll do that. And then when we apply the function round right there, things that are closer to 1 will round to 1, and things that are closer to 0 will round to 0, right? So if I do same thing, by the way, I can hit the up arrow and go back, right? And rand6 will be like that, okay? Now we want to do it up here, not here in this console, but we actually want to do it up here in our script, okay? So we can write exactly what the book has, rand 6, okay, and we can run it. Several ways you can run it. I can do run section like that, and it will generate me a matrix, and it's calling it A. I can also click right here in this little blue bar, and it will run it, and it makes another matrix there for me. And these matrices are different, right? If I do it again, should see something change. Like there's these two ones, 2 zeros, and 2 ones. Right, do it again. We get a 1, 2 zeros, a 1, a 0, and a 1, right? So this is changing each time I do that, okay? If we want to define A and not show it, I put a semicolon after there, and I can run it. So now A is defined. There it is right there. Right here, we can just make sure about this. Let me clear these again. So there, everything's gone, right? So there's no variable A, but if I run it here, right, there it is. And I think we can inspect it. Let me see. There we go. So I click on it, it'll pop up and show me what it is. Okay, so a little debugging tools here and stuff. Okay, now the question we're going to ask is this matrix singular? Is it invertible? Okay, singular means non-invertible, right? So we're going to we're going to try to find the percentage or the probability that a random matrix will be non-invertible, which is the same as saying it's singular, right? So one way to say it's singular is say the determinant's 0. So we can write determinant A. This will just compute the determinant of A. And if I want to decide whether or not it's singular, I can type equals 0, right? And this thing here will be true if the determinant of A is 0. So that means that A is singular, right? And by the way, we can put comments in here like this. True if A is singular. Okay, so we can do that. Now we can run this kind of thing, repeatedly and just get a feel for what's going on. So I run it. All right, and I get 0, that's the same as false. Okay, so I run it. 1, that's true. Okay, do it again. Another 1, that's true. So 2 1s, 1 0, run again, get a 0. All right, so far we're getting like 50%. Do it again, get another 0. So I got 3 zeros, 2 1s, 4 zeros, 2 1s. Oh, 5 zeros, 2 1s. Anyway, you get the idea. You keep going. There's another 1, so 5 zeros, 3 1s, right? Okay. And we don't want to do that by hand, right? We actually want to use MATLAB to keep track of that. So here I'm going to add a new cell down here where we're going to try to automate that. Okay, so insert, and I'm going to do a section break right there. Okay, and I'm really just using the code from the book here. So we're gonna define a vector of zeros. So this will give us a vector of a 1 by 100 vector of zeros. Okay, so one row, 100 columns, right? So a long, horizontal vector of zeros. So y equal zeros, 100. Okay, and then what we're going to do is we're going to go through the numbers from 1 to 100, and each round we're going to define one of these random matrices, and then we're going to set the jth element. So right now these are all zeros. We're going to set it equal to 1 if our matrix is singular, right? So that's what this for loop is going to do. So for, okay, and you guys are supposed to have done the Onramp for MATLAB. So some of this, for loops and things like that, you should be a little bit familiar with. So I'm going to say I equals 1 through, was it 100? I think we're doing out to 100. Right, and it's going to fill in part of this. It's going to put an ending in there for me. That's nice. And I'm going to set my matrix A equal to round rand 6, right? Okay, and I definitely don't want to show this each time, or I just get a bunch of matrices flying by on the side. I'm not interested in that. And then I'm going to set yi equal to the answer to the question, is it singular, right? So this is going to be det A equals 0, right? And again, I'm going to hide the output so I don't see that all flying by. Okay, so this is going to define the thing as zeros, which we also don't need to see. Okay, and then it's going to go through this loop and it's going to change these to 1s whenever our matrix, and by the way, note if I hover there, it'll actually show me that my matrix there. That's from this previous version. It's going to define these to be 1 when the matrix is singular, right? And then to get the percentage of singular matrices, we'll just sum up the final value of y. So when we sum up all those 1s, it'll just count how many times it was singular and divide by the length of y, which is 100, right? And we'll get our percentage, okay? And we could increase this number if we wanted more accuracy to 1,000, 10,000, a million, whatever we want to do there, okay? Okay, so let's run that. Right, so I can just run it by clicking on this. Okay, there's no output there, but we see that we've defined our variables here. And let me see if I hover over this, right, we can see some 1s and 0s in there. And if I double click this here, right, we can actually view it right there, our 1s and 0s that we get. Okay. Okay, and now let's just do another section break, and I'm gonna get my, percentage of singular matrices, right? So let's call this percent singular equals, okay, and I'm going to do sum of y, that's just going to add up all the ones, divided by 100. That's how long y is, right? Okay, so we could, let's see, y, trying to remember some of these things I don't remember off the top of my head. Size y, yeah, size y gives 1 to 100. So I think the way you have to do things in MATLAB, I think I can use this as sort of a placeholder variable, and in equals, okay, I think this will define for me a sort of placeholder thing, and an in, and then the in will be assigned to 100. Let me see if that works. I'm not sure if this will work or not. No, it doesn't like that. This doesn't like that. Okay, so in, fine, I'll do that. Okay, so yeah, so see I can assign, so if I look at size y, this is just something to remember, it gives me one in 100, right? So it's a 1 by 2 vector, right? So I can define it. I can define variables more than one at a time, right? So if I do this, it's going to assign m to 1 and n to 100 like that. What you can't do in MATLAB is you can't do this. I can't do like size y, and I want the second coordinate. By the way, this starts indexing at 1, not 0, like Python or something. I can't do this, right, and sort of compose functions. It doesn't let me do that, which is too bad. That would make the language better, actually. Anyway, we can run this, okay, and let's see. So we get here 64% singular matrices this time around, right? If we want to redo this experiment, I can run that again, and I get 57% singular matrices. All right, so you can do this over and over. And like I said, you can increase this. Actually, let me just put another variable in here to let us increase this as we go. So let's say I'll set the variable in equals, let's say 1,000 now, right? And so instead of changing all these things, I'll just call this in, right? I think that's it. Okay, and then here I want in, okay, like that, right? So like that, I can do that. Okay, let's see. So I got 59.6% singular. So let's do that again. All right, okay, and 60 singular, right? So pretty close to 59%. That's what we're seeing here, right? Okay, and that's really basically what this is asking you to do, right? It asks you to do those calculations. And then in the next part B, it says, now let's change this. So right now we're getting a random matrices of 1 and 0s. If I wanted a random matrix of numbers between 0 through n, right? That's n plus 1 many numbers. You have to be a little bit careful there. Then what I can do is I can just multiply this thing by n. Okay, so I'm going to add this to my code. So n equals 1. That's the case we're currently in. And I'm just going to put a in there, right? Okay, and so this is just going to repeat the very same experiment we just did. So we do that. So we should get something close to 60% here. 56%. Okay, so a little bit different. But if I wanted now to change to a different number, I could do 2, right? So now I'm going to get random matrices where the entries will be 0, 1, or 2, right? Because we're going to take a random number between 0 and 1. We're going to multiply it by 2. So that's going to give us a random number between 0 and 2. And then this is going to round it to the closest integer, right? And so we can calculate that. And we can say, okay, what's the percentage of singular matrices there? And so it's gone down, right? From basically 58, 59% down to 12%, right? We can do it again. Okay. Run it again, and we get around 13%. Okay, that's not surprising because as we increase, like as we look at random matrices where we have more numbers allowed, right? Then it's less likely that the various rows or columns will be linearly independent. Okay, so they're less likely to be singular, right? So as the set of numbers we're using in our random matrices increase, the chance that we get a random matrix is going to, the chance that we get a singular matrix will decrease. So if we go up to 3, right, you can do this experiment. Okay, so now we got that, and I can click this, and now we're down to just 2.3%. All right, and again, we can repeat that. Okay, repeat it. All right, 2.1%. Okay, now all this repeating I'm doing, I could code that into the code too, and I could even code in a thing to make a plot as we run through various ends, right, for the thing. Let's see. So this one doesn't ask you to do that. No, I'll do it anyway. Let me just go through it. I mean, we've done everything that this problem actually asks. So you don't need to do this next thing, but it's fun to sort of plot stuff and look at things. I will say this, you can, I can start here and I can add a section break and change it to text. And I can say something here like, let's see, run the experiment. You can add text and comments, right? Run the experiment to generate how many? We're generating in many random matrices with entries 0 through n, right? So there are n plus 1 values available, right? And record which of these are singular, right? So you can make comments like that in that text, okay? And then maybe down here, we make another little section break. We'll make this text and we'll say, compute the percentage of singular matrices that were generated in the previous step, right? So generated in the previous step. Okay, and you see I'm not a great typist either, right? Okay, so anyway, that we can do. Of course, I could pull this up here and put it there and then just run that over and over in one step instead of doing two things. But, I'm just trying to show you how to use the sheet. So let's actually add a plot. Okay, so it takes a little bit of work. So what I want to do now is I want to sort of do this step, but I want to run over a bunch of different ends. This percentage singular goes to 0 really fast. So I'm just going to do it for like n, say from 1 to 5. Okay, so that's all I'm going to do. It doesn't make much sense to go much further than that. The other thing you could do is make the matrix bigger, right? You could, instead of doing a 6 by 6, you could make that a variable too and go to bigger matrices. Right? There's lots of things you could do here. So let's do another section break, okay? And what I'm going to do is make another loop, right? And so for let's see. Actually, again, I want to store my data, but this time I want to just store the data for each value of little n. Okay, so I'm going to say x is from 1 to 5. Okay, so that's going to be the values I'm interested in. Okay. I'm going to say for, yeah, that's fine. I guess I can use x for two things. Let's see, I got I up there, so let's say j equals 1 to 5. I could use x again, but I'm going to be changing x along the way, so I think that could cause problems. Just, one of those things to check about the programming language. And then what I'm going to do is on each round, I'm going to do that stuff. So I'm just going to copy this and paste it here. This is another thing I forget. I think you need the indentation right here. Although I don't remember. I mean, I guess I could leave it unindented, but let's indent it to make it pretty. Let's see, and I think, okay, there we go. So we've got the indentation all in there. Okay, so this is going to go, for values j from 1 to 5. Actually, let me call this n because I called it n before. Okay, let's call that n, and we're going to collect our data. We're going to set up our y vector of zeros, and we're still using the same 1000 from above, right? And then, and so we're going to collect that data for each n, and now I want to compute this thing. Actually, yeah, what I want to do now is I want to assign xi equal to this thing, this percent singular, right? So just this value here. Okay, so it's gonna do what I was doing by hand up here, but it's gonna do it all at once. It's gonna do one round for n equals 1, one round for n equals 2, and it's gonna then put those together in its own little vector, and then we can plot it. Okay, so let's see if this runs. Okay, so like that. It did. Okay, so it gave us our stuff. Um, it says x is 1,000. Let me make sure. So x was 1 to 5. Oh, I did xi. That was silly. Sorry, it was actually doing xj, right? I wanted to do this for j. Okay, the x should only be 5, right? This turned out to be 1,000. So let's try running that again. Okay, that's better. There's x right there. So 1, 2, 3, 4, 5, and it didn't like me changing it like that. Okay, hold on just a second. Let me try a slightly different thing. Okay, I'm going to do the zeros. 1, 5. So sometimes you have to play with things. Let me see if this works better. Because I expected that to change. So let me run this. There we go. And now I got, okay, zeros. Oh, well, let's print x and see what we get. Okay, so it may just be rounding in here. Let's see what happened. Let's see, yeah, let's do another section break. Okay, so let's just take x and let's print it real quick. Get a view. No, it looks like it's just, let's see, what is it doing wrong? What is it doing wrong? Why is it doing this? X is zeros, Y is that. Let's see, X is that. And just make sure I'm not doing something silly. A is that. Y, I. Oh, what J? There's no J. Yeah, sorry. I had called this J the first time, but I need to call it N. We'll get it straight here sooner or later. Okay, let's run that again. There we go. So now we're getting values out that make sense. Okay, so let's see. Here we go. All right, so when we have n equals 1, we get 57%. Singular, we have n equals 2, right? So these are 6 by 6 matrices of random numbers between 0 and 2. We get 14% singular. These are 6 by 6 matrices of random numbers between 0 and 3. So there's 4 possible entries. We get 1.3%, and you see it keeps going down like that. So that's the way this goes, okay? Then if you want to plot this, you could just literally type plot. Okay, and this is probably not the kind of plot you want, but let's just type plot and see what we get. So we type plot, and we get a plot like that, where we get this kind of piecewise linear function, showing this. We probably want it to just show the values at those things, more like a scatter plot, right? So for that, we can just change the plotting. So I can just put a dot, and it'll give me a dots. Let's leave it blue, so blue would be B there. And we can plot that, right? And then I just get these dots. Now those dots are really hard to see, so I could make them like little circles, and you can change their size and stuff. I forget exactly how to do all this stuff, but there we get these little circular dots, right? You can see them going down. So that plots, right, the percentage of singular matrices for these various values. And the only tick marks we're actually interested in is 1, 2, 3, 4, and we could probably set those tick marks, but I'm not going to try to remember how to do that in real time here. Or maybe format these as percentages instead of decimals. There's all sorts of things you could play with, right? But this is already doing more than the problem asks you to do. But basically, that's how you do this, and then you save it, of course. Okay, and you can just hit Control S, right? That'll save it, right? This little star, right? If I type some stuff, right, the little star comes. It means it's not saved. Control S saves it. Okay. You're going to put it in your shared file, right? So if I come in here, let's see, I forget where all my shared stuff is. Anyway, somewhere I have all my shared stuff. I'm not seeing it at the moment. Um, anyway, well, okay, not sure where it is right now. But you would put your work here, save this into the directory you shared with me, and then I can open it up online and run it and see that it runs. Look at your comments, whatever your comments you make, and anyway, that's sort of what you're supposed to do. So hopefully this helped. I'm kind of recording this quietly because it's late at night and people are sleeping. So hopefully you guys can hear it okay. All right, thanks.